presentations, which were covering a real cross-section of the whole design computation world, both laterally as well as vertically. If you think about both scale, spatially, and in the context of time, as well as future casting in Kara's work, where you're trying to, what might happen, what are the impacts for things that might happen in the future, and networks of dependency. So I would really just go one by one, and I would actually just ask one very general question, which is an identification of one common statement that seemed to be shared by everybody, which is, it would be great if there were common standards and if everyone would use them. And I'm never quite sure if it's a question of do we have the skills or do we have the awareness? Sometimes the pendulum sort of swings between, yeah, everyone knows, but for all kinds of organizational reasons, there's some resistance. And sometimes this pendulum swings in the other direction, is that actually no one knows. And I sometimes wonder that the International Standards Organization and maybe the national standards bodies could sometimes help us with access to the standards, because the deeper you go into it, the more money you end up spending as an organization to have an entire set of current standards. And also remember that they're in evolution. They're not this, stone tablet that comes down from the hill and then that's it forever. No, not at all. For any of you who have gotten involved with the committees, it's constantly listening to feedback, fielding questions which are sometimes sent from industry practitioners straight to committee members, get discussed and then get sent back out. So I think I would go to the top and perhaps start with Hans, and just if he wants to share perhaps reflections now that he's seen everyone else's presentations, what his view is of consolidation of standards and how they sometimes overlap and sometimes need to be knitted together to actually deliver an outcome, whether it's to a client or whether it's an institutional research project or I think Hans is, there are so many, but perhaps if I shut up for a moment and Hans switches on, he'll have more. I'll just go through the list. Yeah. So Gary, if you want to.
So some people they were here. Some people had to leave to go to meetings, etc. Yeah. But I think Hans,
Yeah, the problem with standard is there are so many, so you have to choose the right ones. And we see more and more that the RDF scheme triple is that's the one, and the IFC is getting more and more in ports and rails and industry and buildings. So we should focus on those and not on the other ones, I think. And all the standards are more in what I showed you about how do you set up your enterprise architecture. Try to formalize that, try to align that with system engineering, and go further with designs and building interfaces built on IFC standards. That's what I think it's important.
Yes, something I notice, and I think there is a parallel there, is what Credo is becoming and what it is representing and becoming, and what you proposed as the CDE 2.0 as an architecture. Do you think there is a parallel there, or it's a very different architecture between the two things?
Yeah, it's a little bit different, because enterprise architect is about enterprise architecture, but you can also architect ecosystems with it. But to be honest, I don't have the right answer on that, Abel. I think you can connect them. You can use that. Yeah, period.
Yes, it's like all the new ingredients that are not considered in a city, like a city for BIM, for example. But we know they have to be there. And then when we see something like Credo running and collecting all that data and simulating so many things, it does show that some approaches in BIM are lacking on things we should be considering to design our building environment. I think the data it produces and the information it produces is incredibly invaluable for building design as well. So as an infrastructure, is mainly the use cases are, it started as water, right? Water supply. But now it's kind of, the ramifications are growing. You have different systems overlays, and how there's impact on building design is quite interesting, because now we have that data there. I don't know how that data is going to be shared, but is it, and if it is going to be shared, what is the forecast for this?
We've primarily been considering building design in the context of the networks that we've been exploring within Credo. So a lot of infrastructure networks, so like power networks, for instance, they have buildings and other structures they use to house critical equipment. And obviously those are built to a standard. So we've primarily been focusing on that, but yeah, we do want to eventually scale to users who aren't necessarily network operators. So there might be a use case for Credo where you maybe access insights from the simulation, but you don't necessarily contribute data back. But that's definitely an open question.
Right, yeah.
I was going to pass the baton on to Darren Barker, but I'm not sure if the camera looking out the window is an indication that I'm not here, or whether he's just within earshot. So I don't know. Can we ping Darren to, or if not, I was going to field another question, if I may, which was really prompted by the reflection that having too much data is actually burdensome. And one of the challenges is a bit like trying to pose a research question. There's again a spectrum of research questions which are fantastic, really interesting, but they're like unanswerable. We don't have the equipment, we don't have the data, we don't have the regime. And somewhere at the other end of the spectrum are research questions that you can pose, which are easily answered, but actually the findings are more or less inconsequential. They barely help you understand the situation as it is, and they give you very little forecasting efficacy. And somewhere in the middle, there is, I wouldn't say optimal, but there is an incisive research question, which is balanced somewhere on the threshold of the capabilities technically to have the right information collected at the right location with the right frequency and a sufficient quality assurance that you trust it, in the sense that pretty sure the sensors are calibrated and they are representative of the variable that you want to know, and those two extremes. And I just wonder, sometimes we burden ourselves, I mean, I'm speaking for myself here in running research projects, we sometimes burden ourselves with unrealistic data collection regimes, that you just have a torrent. I remember reading a 10-point plan from, I think it was The Economist, of 10 rules for data collection, like the 10 things you don't do. And quite high on the list is, don't collect too much data because you're not going to be around long enough to analyze it. I just wonder if there are any reflections in the different domains which have been presented about that precision, but also looseness in actually collecting the right kind of data that's effective with the sorts of questions you're developing all of the software and the and your sort of infrastructural capabilities to actually answer.
Yeah, maybe I can.
Yeah, Hans, I bet has got.
Yeah, you have also, and Kara also touches is about distributed architectures. But there's also a nice principle, what's called FAIR, F-A-I-R. It's findable, usable, findable, accessible. The I is interoperable and the R is reusable. It's F-A-I. And it's about accessible. It's not about getting all those data in central databases, because especially when it's volatile data, then well, yeah, what's the use case? When do you need it? So the accessibility is far more interesting than storing everything. It's also extremely expensive to do if you store a lot of data in the cloud. So it's also about that edge cloud balance. What's now a very in the foreground of lot of use cases, what you have to build out. What do you on the edge, and what do you in the cloud? And if you want to do risk assessments, yeah, you can do that in the cloud, but you have to access a lot of data and do models on it and do predictions. But in operational twins, for instance, yeah, you can also leave a lot of data on the edge, and you don't have to bring it to a central station. So the the FAIR principle, sometimes it's also called fully AI ready. If you comply to those 4 statements, then it's yeah, you can also try the most benefits from AI from it. But that's a little bit I want to say about too much data, enough data, in the right time, right enough. And there's also another ISO that's not called a lot, but it's about a level of information need that is also looking to, yeah, which information do you need to fulfill your use case. But this search will go on for a long time.
Cara, I don't know if you want to contribute to that question, the applying the FAIR principle in the context of your work.
Yeah, maybe.
Yeah, so I wanted to touch on that point about right time data you just mentioned at the end there, Hans. That's like been a very important part of the Credo project and trying to figure out exactly what data that we need access to. Because I think a lot of people, when they first hear about the Credo project, they assume that we're collecting real-time data on different infrastructure assets from sensors, and we're like, no, like that's not what we're doing. Because the use case is actually around strategic resilience planning. So you wouldn't necessarily need real-time sensor data. That could be different for a different use case, but yeah, I think our goal was to start small and to work, like really try to understand what the target users of Credo need. Because you're right, like there is such a thing as too much data and you're not going to use everything. But yeah.
Yeah, there are many different digital twins, and they all have different functional and non-functional requirements. And that must be every time in our minds. Because yeah, we work a lot with operational twins, where you really need real-time data to give new set points to pumps and valves and that kind of thing. And also if you do that with an automatic loop, control loop, it's a whole different situation than in your Credo project. But still, the core behind it, so the graphs you make on the ontologies, is the same. And that's the very interesting point of digital twins, I think. So the functional idea is always the same, but how you operate it is different. And with operation, for instance, in what I said, in an operational environment, you can also do a lot on the edge instead of in the cloud.
I have a question. So Hans, so all right, yeah, I understand that, and I understand that too much data can be a problem. But how do you know what to throw away?
Yeah, what to throw away, you can also use machine learning models for it. If I take for a water treatment plant, for instance, to train the machine learning models, you don't need every second a set point of a point. You say, okay, maybe once a minute is enough. If the pump is going high, of what is the level of the water in a container or whatever. You can train models, and then you can put those models back to the edge, and there's the frequency much higher to react on. So the training of the models needs less data than the operational phase. And that's throttling, and you have to play with it.
It's just like we had a presentation from Autodesk also in 2021, I believe. And they said, we just collect everything because we don't know when we're going to miss an opportunity. But I think the context is completely different. They are talking about collecting lots of data about the use of an asset or the use of something to understand how to optimize the design of the next generation of that asset. And that's quite different, I think, from the set of problems we're discussing here.
I think collect everything is a kind of lazy, but maybe also quite expensive.
Yeah,
I mean, there's a dichotomy there, that there's one kind of data regime, a data collection regime, which is investigative. Like you kind of know, you think you know what the problem is, and you're trying to figure out, well, you could do a certain class of analysis, and on the other side, it's explorative. You don't know what's there. So this might be what Autodesk, they don't quite know what they're looking for. So they collect everything and then they do the frequency analysis. I think the way I was trying to pose the question was more, what sort of heuristics could be and are being employed, since you're all practitioners, for trying to do that on the investigative side. You know broadly what the parameter space is, and you're trying to temporally and spatially make it effective. But I appreciate the point that there's a difference between trying to train and then pushing it all back out to operate. That they have two very different sort of frequency domains of need. But yeah, I'm just, is it possible to prod Darren to see if he's still there at all? Because I think apart from yourself,
I'm a bit worried about that.
There's no, did he fall off his chair and we're just sort of the screen?
Yeah, because the camera is on. I can see
he passed out. He ran out of coffee.
I hope he's still alive.
Yeah.
I don't know if open this up to all of the other delegates, if they've got questions for the speakers, any of the speakers. If you want to switch your camera on or type in the meeting group chat, if you open up the Zoom chat window, perhaps if you put in brackets the speaker that you'd like to address the question to, and then the question, or just put your hand up from the reactions toolbar down there at the bottom in the Zoom interface.
I can see one of our previous presenters, Kai-Kong Wu, is online. Also, Andrew is online. He presented yesterday. Dusty White is online. So if you have questions or if you want to switch on the camera,
please do.
Yeah.
I'm always curious, so we just keep asking questions because I find the presentations fascinating. But my job as chair is to encourage everyone else to ask questions.